Okay, so I did make a recording of how to subtract in binary, but it was a bit long, so I decided to shorten it down in this video. And I haven't even published the recording, my account isn't verified. So in the last video we talked about addition, I'm pretty sure, right? Yeah, I think we did. Just in case, so I'm just gonna cover subtraction, or maybe even I'm gonna just do subtraction. So to subtract in binary, let's say we have two numbers. Let's say we want to subtract 1101 from 1001. Now 1 minus 1 is 0, so let's just place that. 0 minus 0 is 0, right? 1 minus 0 is 1, and 1 minus 1 is 1. So now, so far this seems pretty great. I mean, it's pretty simple subtraction. It's just, if both of them are true, then turn it off. And if one is true, then turn it on. Now, there is like some sort of logic for this, like NAND XOR, I think. Let me find it. Yeah, NAND XOR. So let's see. So then that's there. So this is a pretty invalid logic. So yeah, that's how subtraction works. But then when you get to something like this is going to get very complicated very fast. So first we're going to go back, and because we're going to add this, it just comes back over here, and we cancel that out for some reason. So we used to have this, and then we split it, and then there's an extra 1, so because we can't put this on here to subtract, we added it, and then it went back, but I just got rid of this. So now we just work with this. So this would be 0, 0, 1. Now, let's see if that makes sense at all. So that would be equal to 1. This is 9 minus 6, which is should not equal 1. So engineers came up with a better algorithm. It's called the 2's complement. My bad. How 2's complement works is that, let's say you want number A, right? Now normally you use number B to subtract, but so let's say we want 1101, which is, hold on, like 11 minus, going left to right, 11 minus 4. Now instead of subtracting these two in general, we add the negative of 1, which is essentially the same. So they invert it, and then they add 1. So this is 11 plus negative 4. So let's add 1, 1, 1, 0, we carry 1. Alright, so let's see. This is 1, 1, 1. Wait a minute, hold on. Okay, that also doesn't make sense. Let me check my recording time. 4 minutes already, wow. Okay. So yeah, that doesn't make sense. I don't know why. Wait. So if we just take this out of the picture, I think we have to do it right to left. Hold on. Okay, so this would be 1, 0, 1, 1, or 1 plus 0 plus 4 plus 8, which is 13. And then minus 2. 13 minus 2 should be 11. So let's invert 2 and add 1. Now let's add. 1 plus 0 equals 1. 0 plus 1 equals 1. And 0 and 0. So let's check this out. 1, 2, that's 3. There's something wrong. I don't think I'm getting it right. Hold on. Let me try this again. Okay, so 1 plus 4 plus 8, which is 13, plus 2, no, not 4, plus, no, minus 4. Minus 4. So we're going to invert it, and then add 1. So we got the same thing. So let's add it. So these cancel out. No, wait. Carry. So that's 3. That's 1. 0, 0, 1. So 13 minus 4 is 9. Okay, so that's how I know it's working. So how do we implement this? Okay, so you guys remember XOR gates, right? Well, I'll just keep it short. Basically, they can invert with an like extra signal. So what we're going to be doing is we're going to be taking our inputs and we're going to be deciding whether they are inverted or not. Okay, so let me just make a subtractor. Wait, no. Wait. 1, 2, 3. And then turn this into a node because we're actually going to be using it. And then we just start chaining, so let's dupe this. Let's make it 4 bits for now. Okay, but we wired it wrong, bruh. Hold on. You need to go through element XOR first. So I'm just gonna give it some space so you guys can see properly. Excuse me. Okay. Okay. Let's wire these up. Then let's wire accordingly. Okay. So now we have 2 of our invert signals, but how are we going to add 1? Now let's say, because it's A plus B, we can do A, it's going to be A minus B, so I'm going to add a switch for that. And how it's going to work is that it's going to add 1 over here. Let me check recording time. Okay, it's 10 minutes. I have like 4 minutes left to record. I don't have verified on YouTube. Okay, so now it's going to invert and add 1. And accordingly, it's -1. Because if you count down from 16. So this should be 0, 1, 1, 1, which is 2 plus 4 plus 8, which is 15. And that's a -1 because it's inverted right now. Or at least should be. So if we do, no, it'd just be -0. Alright, so now if we do 1, that's -1. If we do 2, that's -2. And if we do 3, that's -3. Or at least should be. Let's see it. 1, 0, 1, 1, which is 1 plus 4 plus 8, which is 13. And if we go down from 16, that's 3, so it's -3, yeah. Now how are we going to add the second inversion, or like the second negative number? Well, that's simple. We're just going to add an array of half adders at the end. What these half adders do is that they're just going to add 1 if this one's on. Otherwise, the output will be normal. So we're going to do that. Then it'll chain from one end to the both next inputs and outputs. So here we have our subtractor. So let's say we want 1101 minus 1101. Well, that's not the answer. I guess I'll just debug it next episode.